Good afternoon.
Did Toby let you know he wasn't going to be here?
Yeah.
Okay. He did. I'm proud of him.
He
Later,
did.
but
He did. So we're good with that. Let's see. So there's Weston and Jada. We're good. So what I'm hoping to do today is basically just kind of quickly review some of the stuff that you went over with Professor Blake, and just make sure that we're all on the same page. So I'm actually going to start with the very last problem in 9.1. The last time I was with you, we had like 30 seconds more to go on the practice problem, and I kind of fumbled at the goal line there. So I just want to make sure that we're okay with that, with 9.1. And then I know he went over 9.2. And so we want to go make sure that we're good with that too. So, and then we'll just kind of go from there. Okay. So let's see. So Jada, were you able to take the midterm this morning?
Yeah, I took it.
Okay, good.
Thank you.
Sure. All right. So any questions, comments, concerns before we get started here today? All right. Okay. So again, going back to 9.1, we were going over this last practice problem. And anyway, I just want to make sure that we're good with this. So we were talking about Euler's method of approximation, and it's very similar to Newton's method that we did last semester. All right. So what you do is you are given a first guess of y sub 0. Okay. And so when it says here y of 0 equals 1, that's the same thing as saying the y sub 0 equals 1. So we're going to start with that. So that's like our first guess. All right. So you say y sub 0 equals 1. And so then the y sub 1 is y sub 0 plus, when you plug in 1 for y into the function, so the derivative. So 1 plus y, so 1 plus 1, the last guess, times the dx, which is 0.05. So this is just a calculator operation at this point. So you could actually just put it all in there right there, and you would get 1.1. Okay. So that's your y sub 1. Then you take that and put it in, and you say y sub 2 is 1.1 plus, then you're going to plug in 1.1 in for y up here. So y prime is 1 plus 1.1. So you have 1 plus 1.1 times the 0.05. And so you get 1.1 plus 0.105, so 1.205. So that's your y sub 2. Then you go and you plug that in to get your last one. The y sub 3 is the last one we're going to do. And so it's 1.205 plus, now you plug that in, 1 plus 1.205 times the dx, 0.05. You put that in your calculator and you get your y3. And so the idea is that every time you go through another iteration of the formula, you get more and more exact in the value that you want. Okay, so I think we'd only done about half of that when we went through it before the midterm. Okay. So were there any questions? There been any questions on any of that from 9.1 or anything previous in the sheet? Okay. Well, then let's go to 9.2. Now, again, I think that just looking over the notes, Professor Blake did a fine job on this. And so, but I like to just kind of go through the practice problems on the sheet just to make sure that we're all on the same page, and then it gives you a chance to ask me questions. Plus, I know when, I intentionally didn't have him teach from the guided notes just so you could kind of get another take from it. But, and then I wanted to go over the guided notes with you on 9.2. So this is on first order linear differential equations. So it's kind of like, when you first solve equations back in Algebra 1. You start with linear equations, and then you do quadratics and all this kind of stuff. But the first ones are just linear. And so that's the same thing here, linear. So there's going to be two types in this section, okay? The first type is what we call separable equations. And these are the easier ones, okay? So for separable equations, those are the ones where the dy dx can be split apart. And so there's 3 steps here. Let me clean this up. For some reason, when I move from Talon room to Talon room, is that it throws off the spacing. So step 1 is to rewrite the equation as necessary. All right, so why do we need to rewrite it? Well, it actually goes to the second part. Our goal is to separate the linear, the equation so that all the x's are on one side and the dy's are all the x's and dx's, all the y's and dy's are on the other side. And then once we do that, then we integrate both sides. Okay? But, and this is kind of the big point here at the end, not all differential equations are separable. Okay? So, because if they're not, then we're going to do those too in this section. But if they are separable, this is a much easier way to do it. Okay? All right, so let's say that we're trying to separate. Okay? Now, here's a problem. This one is one that's not separable. Okay? So I want you to see why. See, if I multiplied each side by dx to get rid of that, okay? To get the dx. See, over here I just have x's, but the problem is this side I have x's and y's. And I can't, if I distribute it, then I'm going to have x and y in the same term. I'm not going to be able to separate it. See, if I divide each side by what's in the parentheses, I'm going to have y's over here. That's not going to work. Okay? So this is not separable. Okay? So we're going to learn another way to solve it. But the goal in separable equations is to get all the x's on one side and all the y's on the other. But again, I want you to know right from the beginning, it doesn't work all the time. All right? So this says dy dx times 3y is equal to x squared. All right? So see if you can just separate the dy dx. Get all the x's on one side and the y's on the other. Okay? So this is what you should have. So 3y dy equals x squared dx. Okay? So notice, see, we have all the y's on one side and all the x's on the other. Okay? So any questions on the separation part? Okay, so then step 2 then, we rewrite, separate. Now what we're going to do is integrate both sides. Okay? All right, so see if you can do that. So integrate both sides. All right, so Jada, what's the integral of 3y dy?
I'm not sure. I did the x first.
Okay, so what's the integral of x squared dx?
X is it x cubed over 3?
Yep. All right, so Weston, what's the integral of 3y?
3y squared over 2.
There we go. So you just sort of leave the 3 alone, Jada, and then you add 1 to the exponent, like you did over here. So it'll be y squared, and then you divide by that new exponent. So 3y squared over 2 equals x cubed over 3. And then you have to put a plus c on one side or the other. Doesn't matter which. And that's it. That's all we're going to do to that problem. Because that just shows a relationship between y and x. Okay? All right, now we're going to go through and do the ones that are not separable. And I think these are the ones that Dr. Blake focused on. Okay? So the first order linear differential equation. So this is the standard form. So it's dy dx plus a function of x times y equals another function of x. So the function of x times y, we call that function p of x, and then the function by itself, we call that q of x. Okay? So if we want to put this in standard form, okay, so what we want to do is start off with dy dx by itself. Okay, so we need to get rid of this x. So to get rid of the x, I'm going to divide everything through by x. Okay, and so then I'll get just dy dx equals, okay, so then I'm going to have x squared divided by x. I think I'm going to put in that. So x squared divided by x plus 3y divided by x. So then when I simplify, now the function that has a y in it, I want to move that to the other side. So then it's going to become dy dx minus 3y over x equals x. So this part that I've simplified is just by itself. So the function with the y, so it goes dy dx, and then the function with the y in it, and then the rest by itself. So this is the standard form. Okay? So any questions on that? All right, so the next thing we want to be able to do is write the p of x and the q of x. So the p of x is the function of x in front of the y. So just sort of ignore the y, and so p of x is just going to be negative 3 over x. And then the q of x is what's over here, and so it's just x. Okay, so standard form, and then here's the p of x, and here's the q of x. But you have to put it in standard form first. All right, so go ahead and try practice 1. All right, so Jada, when you've got it in standard form, tell me what it is.
Okay, so I got dy dx e to the x times y plus or equals x.
Okay, so dy dx, and then what?
Or e to the x. I have e to the x over y.
No, you don't divide by y. You just leave that y right where it is. What you need is to get the dy dx by itself. And so what you're doing is dividing by x. So you divide everything by x and you get that. All right, so Weston, what's the p of x?
1 over x.
And what's q of x?
E of x over x.
Okay, good. Okay, so once you put it in standard form, then just sort of ignore the y, and then this function, 1 over x, that's the p of x. And then what it's all equal to, with no y's over here, is the q of x. Okay? So, Jada, this one, it seemed like you were trying to do the separation like we did in practice 0, but we're not doing that here. We're putting it in standard form of the linear equation. So, because these are not separable. Okay? All right. All right. Now, the next thing, and I'm going to put this in the next set of instructions here, but you could write this separate if you wanted to. But we're going to need to use what's called the integrating factor, v of x. And v of x is e raised to the power of the integral of p of x dx. So we're going to need that v of x. All right, now let me show you how that is going to be used, how we're going to use that in the steps to solve these. Okay? So, steps to solving a differentiable equation. Number one, you put it in standard form. So dy dx plus p of xy equals q of x to find p of x and q of x. So that's what we did on the last problem, was step one. Okay. Step two, we're going to find the integrating factor. So v of x equals e raised to the power of the integral of p of x dx. And then finally, the answer is y equals 1 over v of x times the integral of vx qx dx. Now, I'm kind of curious. So last Monday, did Professor Blake give you this formula right here, this number 3? Do you remember that?
I don't remember the third formula.
Yeah, see, here's the thing. It's not in the book. So I just developed this formula just based on my own doing these problems. And so it actually saves you like 5 steps. But this is it. Once you find the v of x, this is the answer. Okay? So 1 over v of x times the integral of v of x q of x dx. Okay? So let's do an example. Do you have all this? Anybody, either of you need more time? Got it? Okay. So, all right. So this is the problem I did in example 1. Okay, where we put it in this form, and then we said p of x was -3 over x, q of x equals x. Okay, so I did that earlier. Okay, so now what I need to do is find v of x. So v of x is e raised to the integral of the p of x. So -3 over x dx. So for this problem, v of x is e raised to the integral of -3 over x dx. Okay? Well, now, if I pull the -3 in front, then the integral of dx over x is the natural log of the absolute value of x. Okay? That's going to pop up a lot. So you need to remember that the integral of dx over x gives you the natural log. So we get the natural e raised to -3, the natural log of the absolute value of x. Now, most of the time in these problems, the initial problem will say x is greater than 0. And the reason it says that is so that we can get rid of the absolute value. Because if x is positive, then the absolute value of x is just x. So we can get rid of it if x is positive. Okay? And then the other thing I want to do is put the natural log of x next to the e. Because if I have e raised to the natural log of x, those are going to cancel and bring down the x, and so I'll just end up with x to the -3. So a little bit of calculus, a little bit of algebra involved there. Okay? All right, now, so this is, now I write the answer, well, and then simplify. So once I have v of x, that's actually the lion's share of the work here. All right, so now, the answer, y is equal to 1 over v of x, so 1 over x to the -3, times the integral of v of x, x to the -3, times q of x, which is just x, dx. All right, so now what I need to do is simplify this, and I'm done. Now, using the elevator rule, remember when my exponent is negative in the denominator, I can bring that up. And so make that just x to the 3rd. And then I have the integral of x to the minus 3 times x to the first is x to the minus 2. And so now to do the integral of that, I add 1 to the power. So negative 2 plus 1 is negative 1. And then divide by negative 1 plus c. All right, so now I distribute this. And I'm going to get negative x squared plus cx cubed. Now, let me just state this, that this part of the integral has a plus c in it. Then when we distribute the v of x through, the 1 over v of x, we're going to have to distribute it to the c here too. So the problems that we've done with integrals up to this point, we just worked it out and slapped the plus c at the end. But here, we're kind of at the second to the last step when we're doing the integral. So we put the plus c when we do the integral. Then when we distribute, this number here is going to get distributed by the c. Okay? And frankly, whenever I make a mistake on these, it's because of that. Because I will, instead of distributing here, I'll distribute here and then put the plus c at the end. And that's wrong. All right? So I'll leave this up here as an example, and you see if you can do practice 2.
Mr. Strong,
Yes.
do you mind if you put the problem on the board? I don't know where my second page is.
Okay, sure. So this first part, to put it in standard form and to do the p of x and the q of x, we did that for practice 1. Okay? So we got down to here for practice 1. All right, so Jada, when you have v of x, let me know.
For v of x, I got and then the integral of 1 over x dx. And would it just simplify the x?
So it just simplifies to what?
X.
To x. Okay? So v of x is e raised to the integral of 1 over x dx. So that's e to the natural log of x. So you just get x. Good job. All right, so Weston, when you have the final answer, let me know.
I think it's e to the x plus c over x.
E to the x plus c over x. So e to the x plus c over x. Okay, or you'd say e to the x over x plus c over x. But the x is multiplied through. So it's in the denominator of both of them. Okay, so not this. Okay, so the x has to be in the denominator of the c as well. So like on a multiple choice test, that would be one of the bogus answers right there. Okay, and like I say, when I haven't like done these for a while, that's where I always make the mistake. That I do that all the time. Anyway. So just to kind of forewarn you there. Okay. All right. So Jada, you okay with that?
Yeah.
Okay. All right. So. Okay. So an initial value problem. An initial value differential equation, you might remember that in Calc 1 when we did initial value problems, it helps us determine the constant. Okay? So it helps us figure out what C is. Okay, so Jada, when I saw your writing, I did send your lab aids all of chapter 9, and some of the sections are very short, or we'll only do part of them. So you probably should ask them to print out the whole chapter for you.
Okay, yeah, she did. It's just I have all of them. She printed for me, but I don't know. It didn't have the second page.
Oh,
I'll
okay.
print it after class.
Okay. All right. So here's an example. It says find the particular solution of 3y and now in this problem instead of dy dx they have it written as y prime, and it's just the same thing. Minus y equals the natural log of x plus 1, where x is greater than 0, for y of 1 equals negative 2. So this extra little condition, that's the initial value that helps you find C. All right? So you just sort of ignore that for a minute. Okay? And then what you do is you solve the equation, just like what we've been doing. So first, you get the dy dx by itself, or y prime. It's the same thing. And then I've got, let's see. So I divided everything by 3x to get y prime by itself. So I get y prime minus 1 over 3x times y is the natural log of x plus 1 over 3x. Okay, so that's my standard form. So the p of x is negative 1 over 3x. The q of x looks pretty complicated. Natural log of x plus 1 over 3x. So we'll see how complicated it really is. Okay, so any questions on standard form, p of x, or q of x? And so now I say, okay, find v of x. So v of x is e raised to the integral of p of x. So negative 1 over 3x dx. Well, if I think of the negative 1/3 kind of out front or to the side, then I just get the integral of dx over x, so I get the natural log of x. So e to the natural log of x becomes x, and then the negative 1/3 is still up top. So v of x is x to the negative 1/3. All right, so any questions on v of x? Okay, so now I set up the answer. Now I say y is equal to 1 over v of x times the integral of v of x, q of x, dx. So 1 over x to the negative 1/3 times the integral of x to the negative 1/3 times the natural log of x plus 1 over 3x dx. All right, so let's see what I can do with this. First of all, when I have a negative exponent in the denominator, so I can use the elevator rule to bring that up. All right, so now let's see. I'm doing the, wow, I should have shown more work here. Let me just see here. Okay. So what I'm doing here is doing the integration by parts for this. Here, let's go back down. Okay. So let's see. How did I get that to be 4/3? Oh, okay, I'm simplifying. I was like, what happened there? So this is x to the 1/3. Here, let's write this to the side here. So if I have x to the negative 1/3 divided by x, okay, so this x right here. So then I subtract negative 1/3 minus 1, so that gives me x to the negative 4/3. Okay. So now to integrate this, I'm going to do integration by parts and say, okay, let's let u be x to the, let's see, so u would be ln of x plus 1, dv is negative 4/3 x. The 1/3 I'm going to just pull out front. Now, why did I select it that way? Well, because it's easier to take the derivative of this than the integral. The derivative of natural log of x is easier than the integral of natural log of x. So if I say the derivative du is going to be 1 over x dx, the derivative of 1 is 0, so that goes away. And then the integral of this, we take x to 1 higher power, so negative 4/3 plus 1 is negative 1/3, divided by negative 1/3 is the same as multiplying by negative 3. So now I have u times v, so natural log of x plus 1 times negative 3x to the negative 1/3 minus the integral of v du. So negative 3x to the negative 1/3 times 1 over x dx. And then the x to the 1/3 over 3 out front. Okay, so let's see. So if I distribute that through, x to the 1/3 and x to the negative 1/3, those are going to cancel. So I just get ln of x plus 1 see, the 3's cancel, the x's cancel, minus, and then when I distribute it here, so I just put that here, bring the negative 3 out front, we'll make that positive 3. It's getting multiplied by. And then x to the negative 1/3 over x is x to the negative 4/3 again. So now to integrate that, I'm going to raise that to one higher power, and then divide by negative 1/3 is the same as multiplying by negative 3, and then plus c. So distributing the negative natural log of x minus 1. Okay. Again, when I distribute x to the 1/3 and x to the negative 1/3, those give you 1. So you just have negative 3, and then x to the 1/3 times c. And so then when I simplify, the negative 1 and the negative 3 become negative 4. All right, now that one, the integration step was a little messy on that because I had to do integration by parts. And I frankly admit that those are the hardest ones of these. When you get to the point where the integration step is awful, or at least a little bit messy. But now, the whole purpose of this problem was to show you that now you can figure out what c is. So if you go back to the top, and we were told that the y of 1 is negative 2. So if we plug in 1 for x and negative 2 for y, then we can figure out what c is. So the natural log of 1 is 0. 1 to the 1/3 is 1 times c is still c. So we get negative 2 equals 0 minus 4 plus c. Add 4 to each side, and I get c is equal to 2. So then I plug 2 back in for c, and so my final answer is y equals the natural log of x minus 4 plus 2x to the 1/3. And so that's the original equation. So I'm given the derivative, the dy dx, or some form of it, y prime, and then I'm able to come up with the original equation, including the c. Okay? All right, so let's see if you can do that before the bell rings on us here, before we end class. So let's try that last practice problem. So the particular solution, that means you have to find c and plug it in. But you do that last. Oh, wait a second. Actually, I'm giving you the answer here. This was the answer to practice 2. Okay? So, Weston, you might remember this. So you gave me that answer right there. Okay? So all I'm asking you to do is plug in this and find c. So plug in 1 for x and 2 over e for y. and see if you can figure out what C is. All right, so Jada, when you've got it, let us know. Or yeah.
Wait, so 1, would you just plug in 1 for x?
Yep. And 2 divided by e, and for y. So you get 2 over e equals e the first over 1 plus c over 1.
Yeah, that's how far I wasn't sure though.
So how do you solve that for c? Well, you just subtract the e. And so you could say 2 over e minus e. And then if you wanted to get a common denominator and add these together, you could multiply this second fraction by e over e. And so you'd get e squared over e. So then you get a common denominator, and so you get 2 minus e squared over e. But you could leave it as 2 over e minus e. I mean, that's fine too. But then once you figure out what c is, then you go back into the problem, the original problem, and plug that in. And so your final answer would be y equals e to the x over x plus 2 minus e squared over e over x. Because it was c over x. So once you get the c, you just plug in, this is what the c is right here. So you're just plugging that in. Okay. All right. Well, that's it for 9.2. And so I don't think, we'll just start in with 9.3 tomorrow. Okay? All right. Well, you guys have a great day. We'll see you. So Weston, Mr. Frank says he expects big things out of you at Skills USA.
Yeah, I spent a lot of time on the thing I've been working on.
Oh, okay.
So, yeah, it's a welding sculpture, and so.
Nice. Well, you have to let me know how that goes.
Okay.
So we'll see you. Oh,
that's going to be coming up.